All right, guys, let's wrap this up. I appreciate that you've been working hard. There's a lot of information in this lesson. It probably seems a little weird and uncomfortable right now, but it will sink in and you'll be okay. Remember, if you want to ask me questions, either to clarify the information on the video, if you want to ask me for homework help, come by tomorrow morning before school. I'm here for you. Okay? So if f is continuous on a closed interval AB, and if f of a does not equal f of b, okay, keep in mind, what does what I've just said mean? If f is continuous on a closed interval, all right, so that means if you've got a left definite endpoint and a right definite endpoint, which I do, and if the graph is continuous between them, meaning without picking up your pencil, you can trace from one end of the graph to the other end of the graph, and you can go from left to right without encountering holes, poles, or jumps. And if f of a does not equal f of b, so that means if the y coordinate that goes with your left endpoint is not the same as the y coordinate that goes with your right endpoint. In other words, look, the y coordinates are definitely different. So in other words, either the left endpoint is higher than the right endpoint or vice versa. Okay? Then for any k value between f of a and f of b, for any k value between f of a and f of b, that means for any y value that's equal to k. So any k value on the y-axis that falls between the lower and the upper tick marks I've already labeled in red. There's going to exist an x value between a and b. There exists c between a and b. All right, well, a and b, guys, are x's. So now I'm saying there exists an x value, which we'll say is x equals c, that falls on the x-axis between a and b, such that f of c equals k. Okay, what this is saying, in other words, kind of in everyday words, you've got some point a, f of a. It is connected via the graph to some other point, b, f of b. All right? If you can find a y value, which I'm calling k, between f of a and f of b, then I know that there is a point c, comma k on the graph between AF of A and BF of B, okay? And I know that the C value has to be between A and B, and that the K value has to be between F of A and F of B. So again, C comma K is right here. Notice it is on the graph that connects AF of A to BF of B. So it's on the graph that connects your left endpoint to your right endpoint. That's what the intermediate value theorem is guaranteeing. Now notice I keep calling it the IVT. On the calculus exam, we have to talk about existence theorems, and there are 3 of them: the IVT, the MVT, and the EVT. And you are allowed to use those initials because, again, those are abbreviations that any math person would know what you were talking about. All right, so as I mentioned on the previous video, the intermediate value theorem guarantees you that there's at least one C value. Look at the second graph where I've got F of A higher than F of B again. There's no rule that says F of A must be higher. It just should be different from F of B. So it might be the lower endpoint, and then BF of B might be the higher endpoint. But since this graph is wavy, notice that I'm picking some y value, which I'm calling k, that falls between your f of a and f of b on the y-axis. And when I look at it, I can find a C comma K, a C comma K, and a C comma, sorry, again, that's the board. C comma K. So there's no guarantee that there's just one point that falls on the graph. There could be 15 points perhaps. It depends on how wavy the graph is. But the intermediate value theorem guarantees one. And again, notice that the x values for the 3 points that are on the graph, so the x values C1, C2, and C3, they are guaranteed to fall between A and B. So that is all that we're saying. So it's such a simple concept, people don't get why we even talk about it. But it's only simple if the graph is continuous. Well, look at these two functions. And here, f of x is not continuous. So there might be a k comma c on the graph, but there may not be. So look at this. I've got my left endpoint is lower than my right endpoint. I've got definite endpoints. I'm picking a y value, which I'm calling k, between my upper and my lower y values. But the y value runs right through the discontinuity in the graph. So there's no point on the graph, k comma c, that falls between f of a and f of b. Again, that's because the graph is not continuous. So we get the notion of continuity being important. The second graph, you've got the same issue, that because the graph is discontinuous, the y value, which I'm calling k, that falls between my upper and my lower y, it scoots right through the discontinuity and it never actually hits the graph. So there's no special point c comma k that's on the graph between AF of A and BF of B. All right, so in the case that f of A equals f of B, it sort of becomes what we would call a trivial case because you don't necessarily have to have the graph, like if the graph, for instance, went up and came back down and went back up again, then you would have a k comma c on the graph. But if the graph doesn't have that kind of swivelly action, then it's not really, like there's not a lot to say because there are no y values that fall between f of a and f of b. So it's just sort of the trivial case. It's not really something we're concerned about. Now, you'll see something where this takes on meaning in the next chapter, but right now, not so much. All right, so what kinds of questions might you have? So a final tough but common IVT-related question. Will there be a C on 0 to 3? Remember, guys, will there be a value x equal to c that falls between x equals 0 and x equals 3, such that f of c equals 4? So I'm saying the y value is 4. All right, what you've got to do is decide, are the conditions set forth by the IVT met? So step 1, the first question is f of x continuous? All right, well, what kind of function is f of x? It's a cubic function. It's a polynomial function. Those are continuous for all real numbers. So f of x is a continuous polynomial function. If it's continuous for all real numbers, it's definitely continuous on 0 to 3. Well, that's only the first condition. The second condition is that my endpoints must differ. So I need one of my endpoints to be higher than the other endpoint. So the second thing you need to do is actually calculate your endpoints. So f of 0 equals -2. That's an easy one to plug in. So FYI, that means your left endpoint on the graph is 0, -2. All right, well, what about f of 3? Well, 3 cubed is 27. 3 squared is 9. Plus 3 minus 2. So it looks like that's going to be 27 minus 9 is what? 18. And then it would 18 plus 1 is 19. So that looks like to me that we're saying that our right endpoint is at 319. All right, so what else do we need to satisfy? Well, this is like doesn't matter if the y value that we're wondering about, if it doesn't fall between the two y values of the endpoints, then it's a no-go. We'll notice that your y values, let's see here, negative 2 is your lowest y value. That's less than the y value 4, which you're questioning, and your higher y value of an endpoint's 19. So since the y value in question is between the left y value and the right y value, we're good to go. So now the result is the IVT guarantees a point C, 4 on the graph between the left endpoint, which is 0, -2, and the right endpoint, 319. Remember, I know the graph has got to connect those 2 points without any breaks in the graph. So C, 4 is going to fall on that connecting piece of the graph. And so, moreover, what we're saying is that C is going to be between 0 and 3. Okay? So that's the deal. Since my y value 4 falls between my y values of -2 and 19, then my x value, which I'm calling C, falls between 0 and 3. Now, if sometimes I'm just saying, is it there? So I've proved that it's there. Sometimes you're asked one more thing. Well, the one more thing says, if such a C exists, find it. Okay? So on this one, I know I've got to say that f of C, which would be C cubed minus C squared plus C minus 2, I know that that y value is going to be 4. So what I can now do is solve for C. So let's see here. If I were going to solve the polynomial equation, I need to put all my plain old numbers and everything else on the left. So that would be -6 equals 0. There's 4 terms. Oh, goodness, guys. We're fixing to get into some good stuff here, good review. There's 4 terms. I would like to group it, but it's not going to group because the ratio of C cubed to C squared, which is 1 to 1, as far as their coefficients, does not match the ratio of 1C to -6. So how could I solve a polynomial function or a polynomial equation that doesn't group? Wait, let me think. Aha, rational root test, synthetic division. So the rational root test is going to tell me that I need to try +or-1, +or-2, +or-3, and +or-6. So let's see here. I'm thinking I am in my head plugging in 1, but that would be 1 minus 1 is 0, plus 1 is 1, minus 6 is 5. If I plug in -1, I would have, I'm doing scratch work and erasing so you can keep up with me. I'm looking at f of -1, so that's -1 cubed minus 1 squared plus a -1 minus 6. Okay, yeah, looks like I'm going to have to plug in some positives. So how about f of 2? 2 cubed is 8 minus 2 squared, which is 4, plus 2 minus 6. That's going to give me 10 minus 10 is 0. Yay, I found one. Well, now what you would do from there is say that 2 goes into 1c cubed minus 1c squared plus 1c minus 6. Bring down 1. 2 times 1 is 2. Bring down 1. 2 times 1 is 2. Bring down 3 is positive 6. So I know that I now have c minus 2 times c squared plus plus 3 is 0. Something tells me that the second part is going to have non-real roots. I can't factor it, so c equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so look, that's going to give me under the radical 1 minus 4. So my other roots are non-real. So the only significant root I have is c equals 2. And notice that 2 does fall between 0 and 3. So that was the c value that I was looking for. And I didn't think I was going to have room to finish the problem without going to a new slide, but miracles never cease in this class. All right, guys, good luck finishing up the homework. You've got a few more problems to do, and I will see you on Thursday. I'll look forward to it. Bye now.